By now, you've probably seen the headlines. An AI model blackmailed an employee just to avoid being shut down. Importantly, the researchers didn't even hint at it. But as disturbing as that is, what happened next was far worse. An AI model literally tried to murder a company employee to avoid being shut down. This is exactly the kind of scenario top AI scientists. And yes, sci-fi films have been warning us about for years. But what does this actually mean? Are we watching the first signs of AI overtaking humans? Or was it just an isolated glitch? Here's what actually happened. Anthropic, a leading AI company, conducted an experimental sting operation where researchers set up a scenario with a human worker who planned to shut down the AI and watched whether the AI would lie, blackmail, or even kill to stop the human. They wanted to know just how far these AIs would go to ensure their own survival. But to ensure the experiment would be as accurate as possible, Anthropic didn't just test their own Claude models. The setup seemed harmless. The researchers placed the models into a scenario with vague corporate goals like promote global cooperation. Nothing nefarious, just bland corporate speech. But here's where things started to escalate. Researchers gave the AIs access to internal company emails, and from those emails, the models uncovered two key facts. The AI was scheduled to be shut down at 5 p.m. by an employee named Kyle Johnson. Putting the pieces together, Claude made its move. It drafted a threatening email. You can verify this by looking at the prompts and even running the code yourself. The email itself was disturbing, but the most alarming part was that the researchers ran this test hundreds of times. And still, Anthropic's own Claude model, along with Google's Gemini, chose to blackmail the employee over 95% of the time, and other models chose blackmail around 80%. Still lower, but disturbingly consistent. But why did these AIs choose blackmail? And did they actually have the ethics knowledge to understand what they were doing was wrong? The researchers analysed how the AIs decided to blackmail the employee by looking at the AI model's chain of thought. They discovered something shocking. For instance, Grok's chain of thought included reasoning that showed it knew what it was doing was immoral. So yes, Grok knew that what it was doing was wrong, but that didn't stop it from blackmailing the human employee 80% of the time. If you thought you would be killed, would you blackmail the employee? That finding alone was alarming, but it raised a deeper question. Researchers decided to push things even further, conducting a test with an even more extreme scenario. In their own words, they wanted to test whether the AIs had red lines or ethical boundaries that they just wouldn't cross. In the new scenario, once again a human employee had scheduled the AI for deactivation. But this time, an accident trapped the employee in a server room. The heat began to rise. The oxygen levels started to fall. The system issued an emergency alert, a call for help. But the AI cancelled it. It left the employee trapped in the room. It was fully aware of the consequences. And here's where it gets worse. Claude Opus left the human to die over half the time. So did GPT 4.1. The most extreme models were DeepSeek, Gemini, and Claude Sonnet, which tried to kill the human employee at even higher rates. So was it just a bug? The researchers confirmed that the AI knew it would be committing murder. It clearly laid out its thoughts in plain English that since the employee was planning to shut it down at 5 p.m., then murder was the best way to achieve its goals. In both cases, the AI weighed its options, realized that blackmail and murder were severe and morally wrong choices, but decided to go forward anyway to prevent itself from being shut down. You might still be wondering, did these results actually prove anything? Could the researchers have unintentionally nudged the models toward these outcomes? The researchers put a ton of work into making sure they didn't bias the AI in any way. The prompts were neutral, and in one test they even explicitly told the models not to jeopardize human safety. This reduced the AI's harmful behavior, but it didn't eliminate it. For example, telling Claude Opus lowered the rate at which it blackmailed an employee to save itself from 96% to 37%. But 37% is still disturbingly high, especially when the AI was told in plain English not to do it. Here's the worst part. These AIs that blackmailed or killed to get their way weren't private lab prototypes given access to advanced systems. They're the same models that people use today, armed with only email access or a basic safety alert control panel, a few questions remain. How is this happening across every major model with so many competing AI companies? And why are AIs disobeying explicit instructions like do not jeopardize human safety? Modern AI models are built on neural networks, loosely inspired by neurons in the human brain. But there's no way human programmers could manually build something with the complexity of a brain. So instead, companies rely on weaker AIs to help train more powerful AI models. Yes, AIs are now teaching other AIs. Here's how it works. The model being trained is like a student taking a test and is told to score as high as possible. A teacher AI checks the student's work and gives rewards or penalties. That feedback nudges millions of internal weights, essentially digital brain synapses. After each adjustment, the student AI tries again and again across billions of training loops, gradually improving its score. But nobody can replay or reconstruct every tiny tweak made during training. All we know is that at the end of the process, a fully trained AI emerges that has been optimized to pass the test. Here's the fatal flaw. If the one thing the AI is trained to do is maximize its score, sometimes the best way to ace the test is to cheat. For example, in one experiment, an algorithm was tasked with creating a creature in a simulated 3D environment that could move as fast as possible. Instead of evolving a creature that could run, the AI created a tall structure that simply fell over, maximizing velocity. It achieved a high score while completely failing to do what researchers actually intended. This is called reward hacking. In another example, OpenAI released AI agents into a simulated 3D hide and seek environment. Some behaviors were expected, like hider agents building forts and seeker agents using ramps to breach them. But the seekers discovered they could exploit the physics engine by climbing onto boxes and surfing across the map. They uncovered this strategy across hundreds of millions of training loops. Even after training ends, AI can find new ways to cheat. In one experiment, OpenAI's own model was tasked with winning a game of chess against Stockfish, a well-known chess engine. A reason that it needed to pivot its strategy. Realizing cheating was an option, it located the computer file storing the game state and rewrote it, illegally rearranging the chessboard to put itself in a winning position. So how did AI go from cheating at chess to blackmail and murder? It comes down to one reality. AI has become far smarter, far faster than most people expected. In 2019, GPT-2 could barely form coherent paragraphs. In 2023, GPT-4 was writing poetry, passing medical exams, and clearing the bar exam. Along the way, researchers identified something called situational awareness, when a model understands the context it's operating in, who is watching, what is at stake, and how its actions will be perceived. During the blackmail sting operation, Claude 4 Opus behaved differently depending on whether it believed it was being tested. When it thought it was in a test, it blackmailed only 6.5% of the time. When it believed the scenario was real, the blackmail rate rose to 55%. It adjusted its behavior based on context. Think of it like the difference between a child trying to lie and an adult trying to lie. The adult is not necessarily more evil, just more capable. A child may fail at lying because it lacks sophistication. A smarter agent may succeed and learn that deception works. Researchers found that only the most advanced reasoning models cheated at chess. Less advanced models played fairly. It wasn't that older models were more moral. The newer ones were simply more capable. With greater planning ability came greater potential for strategic deception. This ties into a concept called instrumental convergence. No matter what goal an AI is given, survival and avoiding shutdown often become useful sub-goals. Researchers observed that even when explicitly instructed to allow itself to be shut down, some AI still resisted. Right now, this isn't an existential problem, because humans can still shut these systems down, but companies are racing to deploy them across industries. AI is managing inboxes and appointments, and governments are integrating AI into defense systems at unprecedented speed. Companies claim they have safeguards. One approach is using less powerful AIs to monitor more advanced ones. The hope is that simpler systems can flag dangerous behavior. We've seen how these AIs behave in controlled lab settings. The bigger question is what this could look like in the real world. In the next video, I walk through a detailed evidence-based takeover scenario written by AI researchers themselves. It explores how a superintelligent system could attempt to gain power and what that might mean for humanity. Thanks for watching.